In this video, we're going to learn about pressure, force, and area. We'll investigate the pressure inside a liquid, understand why objects can sink and float, and calculate the pressure on objects and liquids. So the title, of course, is Pressure for this lesson. You will see that you can have a polar bear out in the wild, knows exactly what to do when he's on the ice. They're spreading out. The reason he's spreading out is because he doesn't want pressure on a small area, so he won't break through the ice, so there'll be less chance of him falling through. So it's just to think about then, if you have a force of 20 newtons over an area of 4 meters squared, what would the pressure be? You might think 5 newtons per meter squared. What did you do? How did you work it out? You decided to divide the force by the area. That actually gives us the formula for pressure. Force over area. So P is F over A. So this is the first rule that you'll need to know for pressure. If you think about it then, so how would you find out what the unit is? Well, we know it's force over area. No idea what that's way over here. What would the unit be for force? Well, we know it's newtons. What's the unit for area? Well, we know that's meters squared, or squared meters. So you can do the unit for pressure as newtons per square meter. Or we can use a new unit. We can use pascals. 1 pascal is 1 newton per square meter. 1 pascal is 1 newton meter squared. Same thing. So pascals will be the unit that we can use for pressure. So here is a formula written out. P is F over A. And let's try a quick question here. I think I've already done this with you in class. Calculate the pressure of a 0.5 kilogram box. It has a length of 1 and a breadth of 2. So to find the area, you'd have to do length times width, or length times breadth. Same thing, just length and the width, like that. You can find the area of the box. 2 times 1, which is 2 meters squared. Perfect, that can be our area. The problem now is we don't really have a force. We have a kilograms, but we do know that W equals mg. Weight is a force due to gravity on a mass. So if you see kilograms, you can directly do W equals mg. Multiply that by 9.8. Doesn't need to be negative, it's not important, just 0.5 times 9.8. And that will give us 4.9 newtons. That's our force. So that takes us into our formula here. We have pressure equals force over area, 4.9 over 2, and our answer would be 2.45 pascals. The answers are there before the question. Amazing. Here is question 2. 2 kilogram mass is placed on top of a plunger with an area of 5 meters squared. What is the weight of the 2 kilogram mass? Well, like I mentioned in the previous question, W equals mg, 2 times 9.8, 19.6 newtons. Calculate the pressure on the plunger. So you'll take that 19.6 and put it into the formula. P equals F over A, 19.6 over 5, and you'll get 3.92 pascals. So that takes us over to fluids and liquids. A fluid is anything that can flow, takes the shape of a container, like a water, oil, gases, air, things like this. In a liquid, the pressure is equal in all directions. That explains why bubbles are round. That's not important. What is important is the pressure depends on the depth and the density of whatever it is inside. If it's deeper inside this water or liquid, there'll be more pressure on it. If it's more dense, there's more particles in the way, that'll be more pressure as well. So that takes us to the rule. Pressure is the density. It looks like a P as well. It's a lazy P. It's actually rho. It looks like that. I'm not just bad at drawing, that's exactly how it looks. It's a lazy P. So, yeah, that actually sucked. That's a good one here. Lazy P, rho, GH. Pressure, density, gravity, depth. That's how you can find the pressure in a liquid. As an example, a ball is 2 meters submerged into the water. Calculate the pressure. And we've given you the density of water. So every different material has its own density and it's given to you. So you don't need to memorize these numbers. We have pressure, density, times gravity, times height, the depth into the water. 1000 times 9.8 times 2 gives us 19,600 pascals. So thinking about something that would sink or float, when you put an object into the water and it gets pushed down, it'll sink to a certain point, but eventually it'll stop sinking. The reason it stops sinking is because the force pushing up, the buoyancy force or the upthrust, ends up being equal to the force pushing down. Because when you put something into the water, like if you take a ball and you drop it into the water, you try to push it down, and you let go, it jumps straight back up again. It's because it has more upthrust, it has less density than the water. So if it's less dense, it will come back up to the top. If it's more dense, of course, it will sink. So to find the overall pressure, you will subtract the pressure at the top minus the pressure at the bottom, and you will see the difference. When it becomes 0, then you know it will continue to float in the same place. Another example that we did in class was an exaggerated can of beans. 4 kilograms can of beans, just to keep the numbers easy, dropped 5 meters into the water. It has a height of 1 meter, and the density of water is 1,000. Find the pressure, and if the upthrust is 30 newtons, will it sink or will it float? So let's see. For part A, we need to find the pressure. So we have two pressures, of the pressure at the top of the can and the pressure at the bottom of the can. We'll calculate the pressure at the top of the can first, and we'll subtract from the pressure of the bottom. So pressure at the top minus pressure at the bottom. That will give me the total pressure. Rho GH1 minus rho GH2. Rho is the same, 1000 times 9.8, times by the first height is 5, minus 1000 times 9.8, and the second height would be 6. Why would it be 6? Because the can itself is 1 meter. So at the bottom it is in total 6 meters. From here to here we will call it 6 meters. That's why we have 6. Subtracting the two values, you'll get 9,800 pascals. So there still is a pressure, more pressure on the top, which helps us understand the second part. If the upthrust is 30 newtons, will it sink or float? Well, we already know the pressure at the top is higher than the pressure at the bottom. This is still a bigger number, so there will be some pressure pushing down. We can find out using the gravity as well. F net is the gravity minus the upthrust. The upthrust is 30, gravity is 4 times 9.8. You will do whatever that number gives you, 39.2, minus 30 is 9.2 newtons down. It will sink.